don't think it's any secret to anyone that water is essential to life. Most of the biological, or actually, frankly, all of the significant biological processes in your body are dependent on water and are probably occurring inside of water. When you think of the cells in your body and the cytoplasm inside of your cells, that is mainly water. In fact, me, who is talking to you right now, I am 60 to 70% water. You can think of me as kind of this big bag of water. Making a video right now. And it's not just human beings that need water. Life as we know it is dependent on water. That's why when we have the search for signs of life on other planets, we're always looking for signs of water. Maybe life can occur in other types of substances, but water is what is essential to life as we know it. And to understand why water is so special, let's start to understand the structure of water and how it interacts with itself. And so water, as you probably already know, is made up of one oxygen atom and two hydrogen atoms. That's why we call it H2O. And they are bonded with covalent bonds. And covalent bonds, each of these bonds, this is a pair of electrons that both of these atoms get to pretend like they have. And so you have these two pairs. And you might be saying, well, why did I draw the two hydrogens on this end? Why didn't I draw them on opposite sides of the oxygen? Well, that's because oxygen also has two lone electron pairs. And these things are always repelling each other. The electrons are repelling from each other. And so in reality, if we were looking at it 3 dimensions, the oxygen molecule is kind of a tetrahedral shape. Let me try to draw it a little bit. So if this is the oxygen right over here, then you could have maybe one lone pair of electrons. I'll draw it as a little green circle there. Another lone pair of electrons back here. Then you have the covalent bond. You have the covalent bond to one hydrogen atom right over there. And then you have the covalent bond, to the other hydrogen atom. And so you see it forms this tetrahedral shape. It's pretty close to a tetrahedron, just like this. But the key is that the hydrogens are on one end of the molecule. And this is, we're going to see, very, very important to the unique properties, or to what gives water its special properties. Now, one thing to realize is, it's in chemistry, we draw these electrons very neatly, these dots up here. We draw these covalent bonds very neatly. But that's not the way that it actually works. Electrons are jumping around constantly. They're buzzing around. It's actually much more of even when you think about electrons, it's more of a probability of where you might find them. And so instead of thinking of these electrons as, definitely here or definitely in these bonds, they're actually more of in this cloud around the different atoms. They're in this cloud that kind of describes a probability of where you might find them as they buzz and they jump around. And what's interesting about water is oxygen is extremely electronegative. So oxygen, that's oxygen, that's oxygen. It is extremely electronegative. It's one of the more electronegative elements we know of. It's definitely way more electronegative than hydrogen. And you might be saying, well, Sal, what does it mean to be electronegative? Well, electronegative is just a fancy way of saying that it hogs electrons. It likes to keep electrons for itself. Hogs electrons. So that's what's going on. Oxygen likes to keep the electrons more around itself than the partners that it's bonding with. So even in these covalent bonds, you say, hey, we're supposed to be sharing these electrons. Oxygen says, well, I still want them to spend a little bit more time with me. And so they actually do spend more time on the side without the hydrogens than they do around the hydrogens. And you can imagine what this is going to do. This is going to form a partial negative charge at the, I guess you could say, the non-hydrogen end, the end that has, this top end, the way I've drawn it right over here. And this Greek letter delta, this is to signify a partial charge, and it's a partial negative charge, because electrons are negative. And then over here, since you have a slight deficiency of electrons, because they're spending so much time around the oxygen, it forms a partial positive charge right over there. So right when you just look at one water molecule, that doesn't seem so interesting, but it becomes really interesting when you look at many water molecules interacting together. So let me draw another water molecule right over here. So it's oxygen. You have two hydrogens, and then you have the bonds between them. You have a partially negative charge there, partially positive charge on that end. And so you can imagine the side that has a partially negative charge is going to be attracted to the side that has a partially positive charge. And that